Hello, my name is Eben. The name of my app is Beijing Weather app. In this app, we will look into four major cities based on their characteristics such as urban, suburban, rural, and industrial hotspots, and their weather outcomes. The main components of the app is data overview, EDA, and model building. Our mission is to use different Python libraries such as NumPy, Plotly, sklearn, and Seaborn, etc. to execute the EDA data overview and the libraries such as random forest to do more machine learning algorithms. And we will be using Streamlit to combine all of them and show it in an application. The first thing I have done is that install the Streamlit library. After that, I have installed the necessary libraries such as NumPy, Plotly, sklearn, and the libraries within that: Plotly, Seaborn, MATLAB, Matplotlib, NumPy, and Pandas. So after that, we have to set a title for the application. My title is Beijing air quality analysis. After that, we have to I have made a markdown which further states what the use of app is, which is this. This is my code for my navigation bar, which is in the left side. So after creating the basic structure of the app and the navigation bar, what I've done is that calling the file. This is the combined df. This is the file which we combine the four selected datasets. This is the pre-process what I have mentioned before. After pre-processing, what I have done is I did the build model in a function. So this is the build model function. What two models I have used is linear regression and random forest. So why I did this first is like it would be easier for me to call them back when I need it. So I did the build model function here, and I will be calling them later when it is necessary. This is the data overview page, and we can see that the number of the data set information here. This is my app. This is the data types and the data information that we are mentioning here. After that, you can see we are visualization of missing values. That is visualizing of missing values. Since we have cleared all the missing values and duplicate values, we can see that it's 0. After that, we are going to enter the EDA part. This is the code for my EDA. I have okay. After calling my EDA options, this is the what I've done is, you can see here, when I select EDA, we can I have done something bit more than what I was asked to do. That is, this is my EDA normal EDA page. You can see that everything is here. This is my code for EDA, and 1 minute. Okay, that's it. So what I have done is this is univariate analysis. What we can do is that here we can see the distribution of uh, PM2.5, which is a pollution variable, and its statistics. So what I have done a bit more is that there's this bivariate thing what I have done. So I can compare two values. So this is the PM2.5 and this is PM10. So what you can see, the values of PM10 and PM2.5 here. These are the four cities we can these are color coded, so I should have chosen different colors, but this city is dominating most of it. And you can see the correlation of here and the individual correlation of each cities. So I made a tick function here. I'll show it to you. This is my univariate, which is the single variable. After that, I have done is I made a select box here. You can see you can select whichever variable you want. After that, you can see it will compare all of the selected variables. This is the bivariate where we can select two variables. So it's basic that we just use the x and y bar and give them two variables, and we use the same as before, the charts. And the multivariate is a multivariable is that we can choose multiple variables. Now I can show it to you here. Multivariate. Here in multivariable, what we do is these are the four cities, and we select the single variable and compare those variables within the city, and we can move here, and we can see the changes in the variable here. You can see this. After that, this is my code for correlation. This is what we have done the same. You can see you can use it for the multivariable here by value. Here, this is the code for the and I have done a bit more about the time series and the time series, but it's the same, but the code is basically the same. It's just different variables. Here the next option in my navigation bar is the model evaluation. Here, model evaluation, what I have done is, you can see I have given a select box. I can show it to you here. This is my model evaluation page. It takes a bit time to load. See here, these are my selected 6 variables. Here, these are the 6 variables I have selected. After selecting, you can select the modeling here. We can select this, and we can select the station for modeling here. We can select this Titan, whichever you want. That's done here. Station. After that feature, we can select different features for the modeling. Here I have included all of the above features which are given in the data sets. And we can evaluate the model. Evaluating the model takes a bit time because it's a bit heavy. I think it's because of the free software. It's taking a bit of time. Here, these are the 2 models I have taken. I have mentioned this before. I'll show it to you again. this is the two models I have used, model for model building. And what we do is we call them here. You see, so it's easier to call a function. I have used a calling it function here. This is what is happening here. So this is the ideal line, and this is also the model actual values and predictor values here. And this is the random forest one. After that, we can adjust the model here. We can delete some of them, and we can select a different station, and this is how it goes. Here you can see the MSC reading, the R square reading, everything is here. Everything is showed here, and this is the perfect prediction and the predicted values. You can see this is how my app is represent the models. So this is the code for model building. So this is the Plotly, and every libraries I have used here is called here. Here I have called every libraries, the linear regression, random forest, the Seaborn, the Plotly and everything for the that's necessary for the maps, the graphs and everything. Here. This is a markdown I given just for the professional touch. This is a Plotly chart figure which uses the values given from the prediction, and this is how it gets the graph is produced in the application. This is the code for my application. So I hope you understood what my basic structure of my application is, or the data overview part, the data expert analysis part, and this is something I have added for my own purpose, like to improve my own learning. And this is also something I have added for myself. And you have to press the evaluate model button to see the models. The next thing is the version control. The version control is handled by using GitHub, and it helps to keep track of your data, your program. So you could go back to the previous code where you left off, or you could continue with your current development. So it is easier when you mess up, you can just go back to the code you previously worked with. So GitHub has been a major help in version control. So it also every time when you update the program, we add a commit, so we can understand what the changes that has been done to the program. So version control has been very easy with the help of GitHub. So this is my app. I hope you understand the basic structure of my app, the code behind it, how we implement EDA, the data overview, and the model building, including the machine learning algorithms, how we implemented it, and I hope you understood that. Um, and I hope you are the version control. I hope you understand how we use the GitHub to improve our version control. So this is my app. So, that's it. Thank you.